Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve this axially loaded bar of length 100 mm and one side we have fixed the cross-sectional area is 10 mm and 10 mm is a square cross-sectional area. Load we are applying is a axially pulling force of 1000 Newton. This problem we are going to solve on material property. The material is structural steel material with an Young's modulus of 210 gigapascal and Poisson ratio is 0.29. So this problem, by solving in theoretical, the displacement in x direction, the displacement is 4.76 10 power minus 3 mm and stress is 10 Newton per mm square. That means 10 megapascal. This problem we are going to solve by using Ansys, and we'll be validating the result with Ansys result and with theoretical result. Okay, let's get started. First go to Ansys workbench. Just wait for a while, it will open Ansys. Yeah, we have got this Ansys workbench. Now here there is option called static structural analysis. Just click this and drop it here. Now it has automatically chosen as a structural steel for engineering material data. Just double click here. Now just go to the model. Our material Young's modulus is 210 gigapascal and Poisson ratio is 0.29. This is a linear static analysis. The two material properties enough to solve this static structural analysis. So here Young's modulus, it has mentioned as 200 gigapascal. Just change into 210. Okay. Now Poisson ratio, it is mentioned as 0.3. Just change into 0.29. Just save this wherever you want to save this file. I just saving here bar_2. Now just we have specified the material data. Two material data is enough for this static structural problem. One is Young's modulus, another one is Poisson ratio. Just go to the project again. We have specified the material property. Now we just want to define the model or geometry. For that, just right click here. There is option called new design modular geometry. Just go into it. Just wait for a while, it will open because it's showing starting. Now it has opened. Now just go to the problem. Our problem is a cross section of 10 into 10 mm has to be extruded to the length of 100 mm. This is our geometry. This problem we are going to solve by using solid element. So just go to the workbench design modeler. Here there is option called sketching. Now you can take any plane. I am taking is a XY plane to draw this. Sketching, taking rectangle and create a rectangle here. Just go to units, change this into millimeter. Now go to dimensioning, specify this dimension, go to general dimension, click here, this is horizontal and this is vertical, and here just specify it as 10 and this also be 10. For fit view, go and click this fit screen window. Just use this pan tool to view here and zoom. To zoom your object, just scroll your before starting, so we have created this section as square cross section. Then go to modeling again. We need to extrude this one, extrude the sketch into using extrude option. Just apply this as a sketch. The extrude length is 100. Just specify this 100. Enter it. Now select this extrude and right click here, generate. Now go to fit screen again. Now you can see this object here. Go to pan tool. Yeah. Use this retro. Again give fit screen. So this is geometry, a bar we have created. Now we have done our modeling our geometry. Just go to generate. Now we have done. Go here, close the design modeler. Now just go to workbench again. Now geometry modeling is done. Now we just want to go for model definitions. So just right click here, go to edit model. Just wait for a while, it will open the geometry from the geometry model. Yes. So this is geometry we have created in geometry model. The same geometry is imported from geometry model to this mechanical, Ansys mechanical. Now here you can see one by one, this is a geometry from import. This is our solid model. Material, click this material, you can check Young's modulus is 2.1 e per 5. Then Poisson ratio is 0.29. okay. Now just go to mesh. Now we just want to make this model into finite element model. For that we just want to mesh this model. For that just right click here, what type of mesh you want. I've just method I want. Then I want to specify sizing. So go to automatic method, select the geometry, select here and apply geometry. So I have chosen the geometry for meshing. Here method they have specified it is automatic method. There are multiple methods we can mesh it. One is tetrahedron, another one is hexa domain. I want hexa element to mesh this. Now this is okay. Now go to sizing, select the same geometry and apply. Now element size it shows 5. I want to divide, I want to make an element of length 2, so that's why I specified as 2. So now just right click here and right click this one and generate mesh. Now you can see the proper hexa element we have generated. That means we have divided this, we have converted this geometry into finite element model. Then we just want to specify our boundary conditions. Go to the our problem. So this is our problem, a bar of length 10 mm cross 10 to 10 mm cross section of length of 100 mm. So this is we have created and finite element model we have modeled it. Then we just want to apply a boundary condition. Here we just want to fix it and here we just want to apply a load of 1000 Newton. So just go to Ansys mechanical. Here select the surface. Here no, just rotate. Pan it here. Select the surface, because positive direction we just want to pull it, this direction we just want to fix it. Select the surface, go to right click, insert, right click, so go to static structure, select the surface, select the surface, right click, insert. We can give it as a fixed support also. Fixed support is nothing but fixing x, y, z direction 0, or we can go for a displacement also. By giving displacement 0, 0, 0 also, the same boundary condition will be the same. So I am using a direct fixed support, so it will be fixed in x direction, y direction and z direction. Instead of that, we can use the displacement also. Apply the displacement of x0, y0 and z0. That means arresting the displacement of x, y, z. The same boundary condition as fixed support also. Now we just want to apply force. For that, select the surface, right click, insert. There is an option called force. Force means here you can go, there is a vector, just choose into components. I want to apply a force in z direction. Just enter the value of 1000, enter it. Now you can see there is a arrow which is coming here. We are just pulling this bar. So now we have applied fixed boundary condition and force boundary condition. A is fixed and B is force. Now we are done. Then we can go for solutions. Go for solution. What are the results we want? That results we can choose it. We want total deformation, we want directional deformation, and we want stress. As 1 is stress, then we wanted stress of normal stresses. Okay. Now what are the results we want? We have chosen here. Then just go to file, save project. Now project is saved. Then go for solving. Just select this one, static structural analysis. Just right click here, solve. Here also you can give solve, or you can click here also to solve. So I am going to give solve. Now you can see the progress, solving mathematical equation. Now the solving is done. Now we can view the results. Before seeing result, you just check the theoretical results, because it is a simple static structural analysis of applying a load in a tensile load. So for that condition, for this condition, the theoretical formula is displacement is PL by AE. So the displacement from the theoretical is 4.76 into 10 power minus 3 mm, and stress equal to load by area. That means stress equal to 10 Newton for mm square. That means 10 megapascal. Let's check the Ansys mechanical, what result it came. Now just go to solution, total deformation. Now this is a total deformation. This is a average deformation of x, y and z, but we want the deformation in x direction. For that, go to directional deformation. We want the deformation in z direction. Change this into x-axis to z-axis and right click here, evaluate the result. Now you can see 0.0047 maximum. So this is the maximum deformation we have got. So here the analytical result also 4.76 into 10 power minus 3 mm. So same results we have got. Now we just want to verify the stress, what stress we are getting it. So go to the analytical stress is 10 Newton for mm square. That means 10 megapascal. Just go to normal stress. This is a stress in x direction, but we want the stress in z direction. Just choose this z axis and right click here and evaluate all the results. Now you can see here the minimum stress is 7.8229 in unit of megapascal and maximum is 16.508 megapascal. But you see most of the area the stress is in the coming in the range of 10 to 11. The stress is coming maximum here because we are fixing this location. We are arresting this location. That's why the stress is going higher. So always we just want to look the stresses away from the boundary condition. Just avoid this location and this location, check the stress here. For that, so just go to node, select any one of the node and right click here, insert, go to stress, normal stresses. This stress we just want to evaluate and check what results we are getting it. Just evaluate all the results and change this axis into Z axis. Again right click here, evaluate the result. Now see, the maximum and minimum, the stress in this particular point node is 10. That means we are getting 10 megapascal. The same results we are getting it. Just go here, go to fit screen. To view in a different view, this is wireframe model. This is the way we can see. So now we have checked with the displacement as well as stress from theoretical as well as Ansys mechanical. Now we can animate this also. For animation, now I just keeping this directional deformation, click this animation. So this is the way load we are applying it. Similarly, we can go for stress also, equivalent stress, just animate. So thank you for this way. In this we have done this axially loaded bar problem. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.